online class, we got you. Wherever you want to from, we got what you need. Today online class, we got you.
Good day, everyone. Once again, you are welcome to Today online class. Just as I've introduced the set of numbers, so the first set of numbers, the first set of numbers are called the natural numbers. The natural numbers. So denoted, this one is denoted as n, as we have it on the bottom. Good day, viewers all over the world. You are welcome to Toydale online class. Today we want to look at differentiation, which is otherwise known as differential calculus. So we just want to lay the foundation of differentiation. So the process of finding the derivative of a function is called differentiation. That is, if you have a function, say y is equal to f of x. If y is a function of x, the process of finding the derivative, which is that is when we now say the derivative of y of f of x, we call it dy dx. It will be equal to f prime of x. So the process of finding the derivative of a function is called differentiation. So this one is this, we call this dy dx. So or the same thing as f prime, the same thing as f prime. So y is called the dependent variable. Yx is called the independent variable. Dependent and independent in the sense that we can know the value of x without knowing y, but we can never know the value of y without knowing the value of x. So when there is slight change in y, the value of y, all of a slight change in the value of x, it is called dy dx. Then it is called the derivative of that function. So that is just its simple introduction to differentiation. And of course, we'll be talking about functions. There are so many functions. We have transcendent functions, we have trigonometric functions, we have exponential functions, logarithmic functions. We have so many functions, polynomial functions. So this function is just a general term. By the time we continue in this teaching, we are going to break down derivative of polynomial, derivative of trig, derivative of exponential functions. We are going to take it one after the other. But we want to establish the fact that the process of finding the derivative of a function is called differentiation. And we denote dy ds. This is dy ds, which is the slight change in one over slight change s, or same thing as f prime. Not only that, f prime is just the first derivative. We can find the first derivative of a function. We can go ahead and find the second derivative. We can have the square y all over the x squared. That will be f prime prime of x. That is the second derivative of a function. We can find it up to the nth derivative of a function. So we should know that. So that's just the general introduction to differentiation. But today we want to look at differentiation from the first principle, and that's what we want to. That is what we want to do today. So today we want to discuss about differentiation from the first principle. Differentiation from the first principle. That's what we want to do today. So irrespective of the function, but today I'm going to use polynomial function as example. I'm going to use polynomial function as an example. So differentiation from the first principle. Let me just use example to explain this. Let's say example 1. The question says find the derivative. Find the derivative of y is equal to x squared from the first principle. So how do we differentiate from the first principle? Y is equal to x squared. Of course, this one now is a function under polynomial function. So it's a polynomial function, x squared. So how do we find that? If you want to use the first principle, there are steps that we are going to follow. The first one is that wherever you have y, you add theta y to it. Then wherever we have this x now, we add theta x to it. So we have x plus theta x. So that's the first thing to do. If you want to differentiate from the first principle, that's the first thing to do. Then the next thing is that you make delta y the substitute formula. Then that simply means that you are going to shift y to the other side. And of course, I can expand this. If I expand this, I'm going to have x squared plus 2x delta x plus delta x all squared, then minus y. So what is y? Y is same thing as x squared. So I'm going to have x squared plus 2x delta x plus delta x all squared minus x squared. Y is given as x squared. So x squared can actually take care of x squared here. So at the end of the day, I'm going to have delta y to be equal to 2x delta x plus delta x all squared. Then from there now I will divide I will divide through by delta x, divide everything through by delta x, divide through by delta x. Delta x can reduce one of this. This can take care of this. At the end of the day, we are going to have from there now we are going to have delta y all over delta x to be equal to 2x plus delta x. That's what you get. Then from here now, we've talked about limit of a function. For us to be able to get dy dx, we have to limit this function as delta x tends to 0. We now say limits as delta x tends to 0. So once we take that, it simply means that we substitute when delta x equal to 0. What do we get? The y dx. If we substitute delta x equal to 0, we are going to have it as what? 2x. This limit as delta y gets to 0 is, we now say hence dy dx is equal to 2x. That is when we take the limit as delta x tends to 0. We are talking about dy dx. And so that is the meaning of dy dx. So once we take that limit, then we are going to get our derivative. So we have been able to get when our y is equal to x squared, the dy dx, which is the derivative, the differentiation is equal to 2x. Okay, that's what we get. That is what we get. So we take another example. We take another example while differentiating from the first principle. Example 2. So this example 2 now, let's take the one that involves fraction. Then let's say find the derivative of y is equal to 3 all over x from first principle. So we go through the same process. So from here now, we are going to have y to be equal to 3 all over x. Then we have y plus delta y to be equal to 3 all over x plus delta x. That's what we are going to get. We get 3. So we make delta y the substitute formula. It will be 3 all over x plus delta x minus y. What is y? 3 all over x. So that will be 3 all over x. Then we find the LCM here. X into bracket x plus delta x. So this in this, we have only x. 3 times x times 3, that is 3x. Minus this in this, we have 3 into bracket x plus delta x. That's what we are going to get. So that's what we are going to get. Of course, we can open up. Here we are going to have 3x minus 3x minus this in this. We have 3 minus 3 delta x. So please divide both sides by delta x. This will be 1 over delta x. Of course, this we cancel this. 3 minus 3 we go. So let me first write this. Let's do it stepwise so that there won't be any mistake. So from here, we have delta y to be equal to minus 3 delta x all over x into bracket x plus delta x. So from here, let's divide both sides by delta x. Then this will be 1 all over delta x. So delta x can take care of delta x here. So that at the end of the day, we have delta y all over delta x to be equal to minus 3 all over x into x plus delta x. That is what we are going to get. That's what we are going to get. Then, if you now find the limit, if you now say limit as delta x tends to 0, delta y all over delta x. If you take the limit, it simply means that wherever we have delta x, it returns to 0. We are going to have it to be equal to minus 3 all over delta x here will change to 0. At the end of the day, x minus 0, x plus 0 is x. We have x times x, that's x squared. Therefore, dy dx, which is the limit, is same thing as minus 3 all over x squared. So if y is equal to 3 all over x, so dy dx, and of course we can write this to be minus 3x raised by minus 3, minus 2. So that is what we are going to get. So now, let's quickly do for the generalization, that is example 3. So the generalization under polynomial, the question says if y is equal to x raised per n, find dy dx from the first principle. Solution. In this case now, we have y to be equal to x raised per n. We know we are going to have y plus theta y will be equal to x plus theta x, everything raised per n. That's what we are going to get. So if we expand this now, we can't expand this directly because it's raised per n. But if you check my video on binomial expansion under binomial theorem, you know what I said, when we want to find the coefficients, when we want to expand something of this nature, raised per 3, 4, I said we can use either Pascal triangle or combination method. But because this one is raised per n, we cannot use Pascal triangle. We are going to use combination method. So if I'm to expand this is what I'm going to get. I'm going to have x raised per n. This will be decreasing with respect to this. Why this will be increasing with respect to this? So this will be x raised per n, delta x, everything raised per 0, plus, of course, we are going to have n combination 0 here. But n combination 0 is 1, to know the coefficient here. Then we go to n combination 1, s raised by n minus 1, delta x raised by 1, plus n combination 2, s raised by n minus 2, delta x all squared, plus dot dot dot. So if you want to expand this now using binomial, go and check my video on binomial theorem. So if you want to find the coefficients, when you want to expand this, we are going to have coefficients. We are going to use the knowledge of combination. So just go and check my video on permutation and combination. Know how to know the formula for combination. Then check my video on binomial theorem. You will understand what I've done here. Then in this case now, when you have n combination 0, it simply means n factorial all over n minus 0 factorial is 0 factorial. I have s raised by n. This one is 0 plus n factorial all over n minus 1 factorial 1 factorial s raised by n minus 1 delta x plus n factorial all over n minus 2 factorial 2 factorial s raised by n minus 2 delta x all squared plus dot dot dot. In this case now, n minus 1 is n factorial. So n factorial is cancelled n factorial. 0 factorial is 1. So at the end of the day, I'm going to have s raised by n here. Plus, in this case now, I can reduce this. This simply means n minus 1. No, it will be n into bracket n minus 1 factorial all over n minus 1 factorial, because 1 factorial is 1. Then I will have s raised by n minus 1 delta x. So this will take care of this also. Then we have plus. Here now, I will change this to n into bracket n minus 1, n minus 2 factorial all over n minus 2 factorial 2 factorial s raised by n minus 2 delta x squared plus dot dot dot. So this will take care of this. At the end of the day, I want to rewrite everything neatly. So I can decide to write everything straight away, but just want to show, because it's not everybody that actually understands this. So we are going to have here, we have y plus delta y to be equal to, we have xn here, plus this becomes n. We are going to have n sn minus 1 delta x, then plus I'm going to have n into bracket n minus 1 all over 2. 2 factorial is 2 times 1, 2. S raised by n minus 2 delta x all squared plus dot dot dot. That's what we are going to have. So from here now, I will make delta y the subject formula. That's believe that it will be minus x. I'm going to have xn plus n into xn minus 1 delta x plus n into n minus 2, n minus 1 all over 2, xn minus 2 delta x squared plus dot 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 minus, that will be minus y, and y is given as x minus n. X minus n. So x minus n will take care of this. At the end of the day, we'll be left with delta y to be equal to n x n minus 1 delta x plus n into bracket n minus 1 all over 2 x n minus 2 delta x all squared plus dot dot dot. So let's divide through by delta x. Let's divide through by delta x. We divide through by delta x. Delta x we cancel delta x here. Delta x will reduce this 1 to 1. Then at the end of the day, if we now limit as delta x tends to 0, delta y all over delta x, the implication is that wherever you see delta x here, at the right hand side, you substitute for 0. We are going to have it to be n x n minus 1. Then everything here will vanish to 0. So therefore, the y, the x, is equal to n x n minus 1. And that's what we are going to get. So if y is equal to x raised per n is a natural number, positive number. It could be negative. It could be negative, it could be 0, it can be integers. N can be integer. So if you are given y to be equal to x raised per n, the y ds, if you didn't go through this first principle, simply means that just bring the power here, use the power will come down, not subtract 1 from the power. That is, if I have y is equal to x raised per n, then my dy dx will now be n x n minus 1. That's how to differentiate directly without going through this differentiation from the first principle. But if you are asked to differentiate from the first principle, you have to follow the step. So this is how to differentiate from the first principle. So I will take the last example, and this last example, I will just take the example 1 and example 2. I will differentiate directly. I won't go through the long process. That is example 4. I will say differentiate the following. A, the first example that I've given, where I decided to, then second one, y is equal to 3 all over x. So no, I've differentiated all this using the first principle. So if we are not asked to do this using, for instance, if you have this question in multiple choice question, you don't need to go through the first principle. Just go ahead and differentiate directly. A, where we have y is equal to x squared. So dy dx, we can get it straight away if we are not asked to show through the first principle. Just bring this power down. That is, we have 2 x, subtract 1 from this power, 2 minus 1. Then at the end of the day, this will be 2 x, 2 minus 1 is 1, that will be 2x. You get your answer straight away. Then the second one also, where we have y is equal to 3 all over x. I can write this as 3 x raised per minus 1. In this is, by the time I take that x to the numerator, it attracts the negative sign. So you know it's a reciprocal. So that is my y is equal to 3 x raised per minus 1. So if I'm to find the dy dx now, the derivative, it will just be, you bring down the power. What you have, this minus 1, you say it's minus 1 times 3 x into bracket minus 1. You just now subtract 1 from that power again. That's how to differentiate. The differentiation of polynomial, that's what we do. Then at the end of the day, I'm going to have minus 3 x raised by minus 2. And if you check the first example and the second example, where we decide to use the first principle, this is what we got. The first example, we got 2x. Then the second example, we have minus 3 over 2. So in general, let me just summarize before we go. In general, when we have differentiation of a polynomial, y is equal to x raised by n could be anything. Dy dx is equal to, bring down the power, n x, now subtract 1 from the power, n minus 1. That is the general form of differentiating a polynomial function. This is a polynomial function. We have so many functions, as I've said earlier on. But if you have a polynomial function, just check the power. You use the power to multiply what you are given, subtract 1 from the power. So this is the general form of differentiating a polynomial function. So when we have a trig function, there's a way we differentiate. When we have exponential function, it has its own formula. Then when we have a logarithmic function, that's when we have the natural logarithm in x. That is, that's what we do. So we are going to we are from henceforth we are going to be taking the functions one after the other, and we'll see how we are going to do the derivative of those functions. Thank you for listening. So if you have any question under this introductory part of differentiation, which is differentiation from the first principle, you can just put it at the comment section. I promise to attend to every question at the comment section. Thank you, and God bless you all.